Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. So we've just got to know some vocab. Faces are where you could lay your hand flat on a shape. Then you've got edges where you can run your finger along. And then vertices are the corners, the bits that you would stab into your finger. So we've got 1, 2, 3, 4, 5 on the front, 6, 7, 8, 9, 10, including the back ones. So a prime number is a number that is only in the 1 times table and its own times table. So 4, for example, is not a prime number because it is also in the 2 times table. 6 is in the 2 times table. 15 is in the 3 times table. 21 is also in the 3 times table. 9 is also in the 3 times table. Now 1 is a bit of a special case. The definition is that it has to be in 1 and its own times table, and technically 1 is only in one of those. So 1 is not a prime number. The smallest prime number is actually 2, but 2 is not in this list. 23 though is not in any other times table, so 23 is a prime number. To find the fraction of an amount, what we do is we divide by the bottom of the fraction and we times it by the top of the fraction. So the first thing we're going to do is 100 divided by that 5, and that would be 20. Then we're going to get that 20 and we're going to times it by the top of the fraction. So 20 times 4 is 80. So our answer will be 80 centimetres. So 55% is the same as 55 over 100. And what I can do is I can divide top of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15, multiply it by 3, which will be 45. So there will be 45 edges. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2, and it will have 30 vertices. So how a frequency table works is the frequency tells you how many are in each group. So we've got 11-year-olds here, and the frequency says there are 4 11-year-olds, there are 10 12-year-olds, 5 13-year-olds, and 8 14-year-olds. So to find out how many there are altogether, we're just going to do the 4 plus the 10 plus the 5 plus the 8, and that will equal 27. So there are 27 children altogether. For this question, we're going to have to remember BIDMAS or BODMAS. So we're going to first of all look and see if we've got any brackets. Well, we do. We've got the 11 squared minus 21 in brackets, so we're going to be looking at that bit first. Inside the brackets, though, we don't have any brackets, but we do have an indice. We've got that 11 squared, so we're going to deal with that first. So 11 squared is 121. So we've got rid of the indice, but we're still looking at the bracket. So we're going to do 121 minus 21, which is going to be 100. Now we have no more brackets, no more divisions, but we do have a multiplication. So it's going to be 300, and that's our answer. When a number is times by itself twice, we write it as 3 squared, or that number squared. When it's times by itself 3 times, we do 3 to the power of 3, or that number to the power of 3. So when we've got something times by itself 4 times, it's just going to be that number to the power of 4. We're going to start off by writing the numbers that the dots are at. So we've got minus 12 and we've got minus 5, and x is anywhere between those. Now, it's obviously going to be greater than minus 12, and it's going to be less than minus 5, but it can equal minus 12, and the reason for that is it's a filled in dot. But it can't equal minus 5 because that is a hollow dot. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So 3 as a percentage of 10, the first thing we can do is write that as a fraction. So 3 over 10. And then I can get the bottom to be 100 and the top will become the percentage. So I can times the top number here by 10. So that becomes 30 over 100. And percent means per 100. Here we've got 30 per 100, or 30%. So the answer is 30%. To get from the length of a square to the area, we square the length. To work backwards, what we do is we square root, because the inverse of square is square root. So we've got 196, and we're going to square root it to find the length. So we work out the square root of 196, which is what number times itself is 196. And you should learn them from 1 to 15, so you should know all of the square numbers from 1 to 15. So you should know that the answer is 14. So the length, therefore, is 14. So to work out what the perimeter is going to be the distance around the square. So if I draw a square out, we know that each of these lengths are 14. So it's just going to be 14 times 4, which will be 56. So for this question, we just need to pick one of the coordinates. I'm just going to pick this one here. And we just need to work out what the coordinates are. Well, it's going up in 2, so it's going to be 4 on this side. And this is kind of 4.5, so that's going to be 19 there. So we know it's 19 at the bottom and 4 at the side here. So we're going to have a look on our table for a 4 and a 19. We've got a 19 and 23 here. It's got to be a 4 and a 19, which is here. And it shows that the 4 is for paper 1 and the 19 is for paper 2. So our answer will just be paper 2. So we've got to first of all find out what the gradient is for our graph. So we're just going to pick 2 points and draw a triangle between them. So I'm just going to pick this point here and this point here. And there's no reason I picked those. Just pick those at random. And we look at how far it's gone across. So it's gone across 10. How far it's gone up. So it's gone from 24 to 36. So it's gone 12 up. And to work out the gradient, which you can call m, or you can just write out the word gradient, it's change in y over change in x. So how much has y changed over how much has x changed? So y is this one here, so it's changed by 12, and x has changed by 10. So it's 12 divided by 10, which is 1.2. Now a gradient represents the amount of change in the y per one change in the x. So for every 1 mile we travel, we're going to go up, it's going to cost 1.2 more. So the interpretation that we give for this context, because this is about taxis, is that the taxi will cost £1.20 or 120 pence per 1 unit on the x per mile. And that's true for the gradient for any context. It's for every one of this, how much of this increases, how much the y increases by. I'm going to first of all work out how many parts there are in total. So we've got James with 9 parts, 6 for Andy, and 7 for Tia. So in total we've got 9 plus 6 plus 7, which is 22 parts in total. And we're asked to find a fraction Tia receives. Now Tia's the last one, so she is receiving the 7 parts. So it's 7 out of 22. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first 2 sticks, the actual combined distance of them, so when we add them together, so be 19 centimeters plus 37 centimeters, is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the 2 lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. It's really important when answering this question that we're really methodical. So we're going to start off just looking at steak. And I'm going to start off with the S. And we're going to pair it with the first dessert, which is the I. Then we're going to pair the steak with the second dessert, which is the mousse. Then we're going to pair it with the third dessert, which is the fruit. So we're being really methodical. We've done all of the combinations with steak. And so we're going to look at burger next. And we're going to pair it with the first ice cream. Then burger. And we're going to pair it with the mousse. And then finally the burger we're going to pair with the fruit. As long as we do things methodically, we don't ever miss any. So with this question, I'm just going to write it out a bit bigger so we can see what we're doing. And one of my rules is if you've ever got a fraction or a set of brackets in a question you're trying to solve, always get rid of those first. So what I'm going to do is I'm going to do myself a little grid to be able to solve these brackets. So we've got a 3 there, 6x and minus 11, and we're timesing them. And we're just going to multiply out the brackets. And if you've got a different technique to do this, that's absolutely fine, use that. 3 times 6x is 18x. 3 times minus 11 is minus 33. So we're just going to rewrite this as 18x minus 33. Now we are solving, so we're going to put our solving lines in. And the first thing I want to deal with is this take away 33. So we're going to do the opposite of that, the inverse, which is plus 33. And whatever you do to the left-hand side, you have to do to the right-hand side. So we're going to add 33 to both sides. We're left with the 18x on the left-hand side because we've got rid of the minus 33. And on the right-hand side, we've got 180. Next, we want to get rid of this times 18. So we're going to do that by dividing both sides by 18. On the left-hand side, we're left with our x. On the right-hand side, we're doing 180 divided by 18, which is 10. So our answer is x equals 10. So we have a set of vertically opposite angles here and here. And we're going to start with those because we have to find out what m is before we can work out what x is. And vertically opposite angles are always equal. So we've got 13m plus 39 is going to equal 2m plus 149, and we're going to get our lines in there because we're going to solve this. And to solve this, we first of all take away the smaller amount of m because we've got m's on both sides. We can't really cope with that when we're solving, and so we've got a 13m and a 2m. So we're going to remove the 2m. We're going to take that away from both sides to start off, and so we're left with 11m plus 39. And we've just got the 149 on the right hand side. Next we're going to remove the number, so take away 39 from both sides, and we've got 11m is equal to 110, and then we're going to divide both sides by 11 to find out what m is. So m therefore equals 10. So we know if m equals 10, we can then work out x, and the way we can do that is the fact that this one and this one are both on a straight line. So they are both on this straight line here. So we know that they've got to add up to 180. So let's write that down. 13m plus 39 plus x is equal to 180 degrees, or I don't normally put that in. For the working out, I always put that in for the answer. So we can solve this, or well, first of all, we know what m is. So it'd be 13 times n, which is 130. And then we can solve this. So let's get my solving lines in. And so that's going to be 169 plus x equals 180. And we're going to just take that away from both sides, the 169. So we've got x equals 11. So the value of x will be 11 degrees. So we can see that the first four of these have already been plotted. Now it's really important that you you do the coordinate the right way around. So the first one is number and then algebra. So we're looking at this coordinate here. We're 18 on number, which would be here, and then 14 on algebra, which would be this point here. 12 on both, so 12 and 12 would be here, and then 21 and 17. So 21 and 17 would be roughly there. Bearings are always from north and go clockwise. So let's have a look at where the north line is. Well, the north line is here. And to find the bearing of B from A, so that means we're at A and we're looking at the angle of B, we're going to go clockwise. And you can see on the diagram it's already labelled as 42 degrees. But the third rule of bearings is they must be 3 digits. So instead of 42, it's going to be 0, 4, 2. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white. So it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91. And that's our probability 25 over 91. Be careful when it say total, you must include all of the outcomes, so red, white, and other. I'm going to start by writing out all the outcomes. So I'm going to start with trout. So for trout, as a main, I could have had biscuits for dessert. Trout as a main, I could have had cheesecake for dessert. Trout as a main, I could have pancakes as a dessert. Then I'm going to move on to a curry for main. So for curry for main, I could have had biscuits, could have had cheesecake, and I could have had pancakes. Now, to work out the probability, it's the amount of successful outcomes over the total amount of outcomes. So successful for this is a curry and pancakes. So curry and pancakes is a successful outcome, so it's just 1. The total amount are 1, 2, 3, 4, 5, 6. So the chance of me picking at random a curry and pancakes is 1 over 6. To find the area of a parallelogram, we use a simple formula, which is the area is the base times the height. Now the base and the height must hit each other at 90 degrees. So this length here is not counted as the height because it doesn't hit the base, which is here, at 90 degrees. The height is this length here, and the base is either this length here or the length at the top. It doesn't matter because they both hit the height at 90 degrees. So we're going to do the base, which is 11, times the height, which is 3, and that gives us 33. Now both of the base and the height are in centimetres, therefore the area will be centimetres squared, 33 centimetres squared. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104. And that will give me 1,216 centimetres squared, because it's an area. To work out the circumference, we need to first of all work out what the diameter of this is. And to do that, we just draw a line across the circle, and we can see the diameter is twice as big as the radius. So the diameter is going to be the radius times 2, which is 28. Formula for the circumference of a circle is just pi times the diameter, which will be pi times 28. Now to write this in terms of pi, which the question asked for, we just put the number first and then pi, so it will be 28 pi. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question's asking is what is the highest common factor of 25 and 35. So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5. And the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5-meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100 because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08. And as a fraction, we can just times top and bottom by 100. So it would be this over 8. So now we can do the bus stop method. So 8 on the outside. And in fact, I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now it says how many bread rolls can we make. Now we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here and here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason. So corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it. So we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides. or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time. And that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through two parallel lines, which are our two north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the two angles are alternate, they're z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. The important thing to realise in this question is that we know a female has been selected, so we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power 16 times 9 to the power 46. Now, when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62, so it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62 take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6, because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. So in this question we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 and 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. So when we're asked to find the position, we're basically finding out what n is. And we're told that the sequence has a 39 in it, and we're finding the position of 39. So we're going to equal the nth term to the 39 and solve it. So we're going to put in our solving lines. And the first thing we're going to do is take away 15 from both sides, because we want n on its own. So we get 6n equals 39 take away 15, which is 24. Then we're going to divide 6 both sides. And so we get n equals 4. So 39 is the 4th term in the sequence. And you could write it out. You could put n equals 1, n equals 2, n equals 3, and just keep going till you get to 39. Or we can do the method we've just done, which is solving it. When translating, we translate with vectors. And the top number in a vector tells us how far right, and the bottom number tells us how far up we go. And to translate to shape, you always pick a point. Now I always pick the top leftmost point, so I'm going to pick this one. And looking at the vector, it says we're going to go 2 to the right. So we do 2 jumps to the right, 1, 2. Now looking at the bottom, because it's minus 4, instead of going up 4, we're going to go down 4. So it would be 1, 2, 3, 4. So our new coordinate for the top will be here. And the next thing we need to do is draw in the shape. So that's the top left part of the shape. And so I'm going to draw in the shape, and it's 4 across. So it should go here. And draw in the shape in there. Make sure that you know that that coordinate is the top left part of our shape. And it says to label it B. To find the lowest common multiple of two numbers, we are going to write out the times tables for each of them. So the 6 times table is 6, 12, 18, 24, 30. And we're going to do the 15 times table. So 15 times table is 15, 30. And we can actually stop there because we're looking for the lowest number that is in both times tables. So if we see this 30 is in both times table, so the lowest common multiple of 6 and 15 is 30. We can write the equation of all straight lines as y equals mx plus c, with m being the gradient and c being the y-intercept. Now the y-intercept is the nice easy one to find because it's just where the line hits the y-axis, which is at -1, so c is going to be -1. Gradient is slightly harder. What we have to do for the gradient is find two coordinates that we know. I'm going to use the same coordinate as I've just found out from the y-intercept, and preferably we want them next to each other, so this one here is a nice one. And the gradient is basically for every 1 we go to the right, how far up we go. And we can see here that we've gone 3 up. So the gradient therefore is 3. And so writing that all out in the equation, it's going to be 3x minus 1. So Pythagoras says that a squared plus b squared equals c squared, and the c is the one opposite the right angle. So I'm going to label this a and b, so it would be 5 squared plus 12 squared equals c squared, 25 plus 144 is equal to c squared, and then 25 plus 144 is 169. And then we're solving to find out what c is, and we're just going to square root both sides. So square root of 169 is 13, so c is 13. The key to estimating is that normally you will be rounding numbers to one significant figure and then working out the answer. So I'm just going to rewrite this fraction here, but instead of 93 we're going to round that to one significant figure, so that will be 90. We're going to round the 265 to one significant figure. Now some people will write 270, but one significant figure means the line goes after the 2, and so that would round to 300. Then 31 will round to 30, and 97 will round to 100. Now the next step is to see things that we can cancel here. So we can divide top and bottom by 10 to make that a 9 and make that a 3. We can divide top and bottom by 100, make that a 3, make that 1. And we can divide top and bottom by 3, so that will make that 1, and that will make that 1. And so at the top we've got 9 times 1, which is 9, and at the bottom we've got 1 times 1, so 9 divided by 1 is just 9, so our answer will be 9. To draw a quadratic graph, we want to find as many values as we can. Because it's a curve, with a straight line graph you only need 3 points, with a curve you need as many as you can get. And now we're actually given a table here to fill out, and so I'm going to start off with a 0 here. And here we want to substitute in the x equals 0 into our equation. So we've got y equals x squared plus 11, so it's y equals 0 squared plus 11. 0 squared is just 0, plus 11 is going to be 11. We're going to do the same for 1, so y equals 1 squared plus 11. 1 squared is just 1, 1 plus 11 is 12. Same again for 2, 2 squared plus 11. 2 squared is 4, 4 plus 11 is 15. Now the minuses are a little bit more difficult, but not that much difficult, because when you square a negative you actually get a positive. So minus 1 squared is just 1, 1 plus 11 is 12. And then minus 2 squared plus 11, minus 2 squared is 4, 4 plus 11 is just 15. Now you can see here we get a nice little symmetry, and we're going to plot this onto our graph here. So 11 is going to be here, 12 is going to be here, so both of these are 12, and 15 is going to be here. Now when you join them up, what you want to do is avoid having a V. Okay, in the mark scheme specifically it says that the bottom needs to be nice and smooth, and avoid something called feathering where it looks like that. You just want one smooth line. Now the best way I find of doing it is turn the page sideways, which I can't do with mine, but you can turn your page sideways and just one smooth line, and we're going to do a nice smooth bottom there. And I just need to lift, try not to lift with yours, and that should be good enough for full marks. Let's just try it again, just have a bit more of a lift like that. That's also good, and I can do this all day. Like the ones that are bad are the ones with gaps, or the ones where they miss points. So if you had yours like this where it just missed that point out, or something like that, that would not give you the mark. You just want one nice smooth, just slip there a little bit, nice smooth, and that probably wouldn't, because you can see that I've kind of hesitated there. So it just takes practice, and as I said, if you turn the page sideways, it's a lot easier to draw a C than a U. There's a 3 on the outside of the bracket, or cube on the outside of the bracket, and cube means times it by itself 3 times. So we're going to times this by itself 3 times. Now we know the rules of indices say when you times two numbers with the same base, you add the powers. So it's going to be 13 plus 13 plus 13, so it's going to be 7 to the power of 39. Now you might notice that actually there's a quicker way of doing this. All we need to do is times the powers, which will also equal 7 to the power of 39. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55, and it's going to be 0.55 times the amount of days. Well, it says the amount of days is X, so it's going to be 0.55x. Then it says that there's just a one-off cost of £15, so you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. So the thing we know about triangles is their angles add up to 180. So what we can do is we can say w squared plus 84 plus w plus 3w equals 180. And let's just put that together. So it's w squared plus 4w plus 84 equals 180. Now, with quadratics, whenever we're looking to solve, we want to have it equal to 0. So what we're going to do is we're going to take away the 180 from both sides, so it equals 0. So we've got the w squared plus the 4w, but we want to take away the 180 from it, which will give us minus 96 equals 0. So with quadratics, when we're trying to solve them, we need to put them into brackets. And to do that, we need two numbers that add together to make the 4 here and multiply together to make the 96 here. So just going through different numbers for 96, and you can try different ones. The first letter in the bracket would be W, the first thing in the bracket would be W. And I think it's going to be, well, it's going to be a positive and a negative to get that negative there. 96 is 12 and 8, so it would have to be, let's have a think. It'd have to be a positive 12 and a negative 8 to add together to make a positive 4, and 12 times minus 8 is minus 96. That works. And to solve, we look at the left hand side first and get that equal to 0. So w plus 12 equals 0, and then solve it. So get our lines in. Take away 12 both sides. W equals minus 12. And we get the left hand or the right hand side, get that equal to 0. W minus 8 equals 0. Lines in. Add 8 both sides. W equals 8. Now we've got two answers here, but it says value of W. Well, we can't have a negative angle, so we know we're looking for W to be positive, so the answer must be 8. So the way this formula works is we have M, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, then the interest rate is on top of that 100%. So our answer here will be 2.9%. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. To start these questions, we always start here and we go down the lines. So it says probability of winning both games. So we're going to go up this one and we're going to pass this fraction here. And then we're going to win the second game. So we're going to go up this one and cross this fraction here. Now the bit at the end will show us the probability of winning game 1 and the probability of winning game 2. So probability of winning game 1 was the first fraction we circled, which was 10 over 11. Probability of winning game 2 was the second one we've circled, which is 4 over 5. The word and in probability means times. So we're going to times the tops, which is 40, times the bottom, which is 55. And we can divide top and bottom by 5, so that will give us the probability of 8 over 11. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the probability of male on a first bus is 9 over 15. And therefore the probability of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word and in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48. and times the bottoms. 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can times top and bottom by 3, and that would be 16 over 75. So either 48 over 225 or 16 over 75. First thing we need to do is expand this quadratic here. So we put down 2 sets of brackets with an x at the start of each of the brackets, and we've got to find two numbers that multiply together to make minus 15 and add together to make that 14. So thinking about it, it's going to be minus 1 and 15. That works for both of them, yep. We get the left-hand bracket equal to 0. And we solve. So we're going to add 1 to both sides to get x on its own. X equals 1. So that's one of our solutions. We do exactly the same thing to the other bracket. Get it equal to 0. So we're going to solve it. So we're going to subtract 15 from both sides, and we get x equals minus 15. So that's our other solution. So here we're given a right angle triangle, and the question involves two lengths and angles, so we know we're going to be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here, we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is. And we can work it out, just briefly, by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labelling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. So we need to first of all work out how many black and red counters there are at the start. Now if you look at the fraction of the probability of picking a black, in your first pick is 2 over 5, and then the second pick is 1 over 4. So you can see that there's 1 less at the numerator and then 1 less overall. So that means we can conclude that there are 2 blacks at the start 2 black counters, and if there are 2 black counters and there's only black and red counters, then there must be 3 red counters, so that to make up the fact that it's 2/5. Okay, so to find the missing probabilities, the first couple are quite simple because we know that, let's do a different colour, this and this have to add up to 1. And so if the probability of picking a black there is 1/4, then the probability of picking a red must be 3/4, because these have to add up to 1. Same with these two, these have to add up to 1. So if we've got 2/5 at the top, the bottom one must be 3/5. And finally, we've got these two here. Now these two here we're not given any fractions for, but given the fact that we started with 2 black and 3 red, we've picked one of the red, so we've got 1 less red, and that means we've got 2 black counters and 2 red counters. So it means that the probability of picking a black is 2/4, or 1/2, and the probability of picking a red is 2/4, or 1/2. To find the resultant vector, we just get the 2 vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and -4 at the bottom. So we're asked to go from B to C and name the vector. So we can't go directly from B to C because we don't know the name of that road. So we've got to go from B to C just going down roads that we know. Well, we know the name of this road, and then we know the name of this road. Now that first road is going to be A, but we're going the wrong way up it. So it's actually going to be -A. And the second road we went down is just B, and we're going with B, so it's a positive B. Now you could write that as B minus A as well. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.